You noticed that we got a warning but not an error when we had mismatched size of arrays. What if we did something like this, where we've made clear it's a declaration of an array on this side, but that doesn't actually match up with the type of array on this side. When we compile main.c and sum.c to object files, the object file will just say there is an array, and sum.o will say I want an array. And it might check the sizes or something like that, but even if we make the size big enough to match, we clearly have a type mismatch. And not only on array, but the result of sum. This actual sum returns an integer where this declaration expects a double. So this call here is expecting a result in a floating point register. This call is producing a result in an integer register, and so random things happen. So there isn't any checking. There's some checking to make sure that all the names match up, right? That all the names we need are bound. There is some amount of size checking, but not checking at the level of types. So that's why we usually put things in a .h file. Anything that needs to be, any declarations that need to be shared among C files, we put it in an H file, and then we use hash include to make both of the C files agree on the same definitions. Right. So in this case, both main and sum see this declaration int array, and so it will make sure that they all agree on the shape of array and on the shape of the sum. The reason the syntax looks different from all the other C syntax with the hash at the start is because it's not exactly C. It's not part of the main compiler. It's part of the C preprocessor. That first step when GCC takes a C program is to apply the C preprocessor, which can be called as CPP directly if you want. And what happens is that it takes that main C file, it sees hash include, and it just copies the content of sum.h into the file. Similarly, sum.h is copied into the content of the expanded sum.c. In this way, they both got the same content. And just as a sort of side effect of doing that expansion, we'll make sure that they agree globally by doing local checking to make sure that declarations match up with definitions. Besides running CPP, you can also get just this stage by using GCC-E in much the same way that GCC-S stops after the assembly step. That'll make it stop after the CPP step.